Okay, guys, so what I want to do is I want to post a little video about factoring. The other day, I think yesterday or the day before, I posted a worksheet with some factoring practice because one of the topics we'll be covering once we return is rational equations, which involves a lot of factoring. So I think it's worthwhile to practice. So just consider this video a refresher in case you forget. So there's three main types that we can factor. Type 1 is by taking out a GCF, which is a greatest common factor. And if you remember, there's two things to think about when you're dealing with a GCF, and that is the biggest number that you can divide by and any variables that your two terms have in common. Okay, so just a real basic example. If we have 2x plus 4, when we go through this, we're looking for the biggest number we can divide by, which is 2. And then do we have any variables in common? And on a case like this, where both terms do not have a variable, they obviously don't have any in common. Whatever it is that you're dividing by goes on the outside of the expression. 2 divided by 2 is 1. So technically this is 1x, but we really don't have to write that 1. And then 4 divided by 2 is 2. So if you remember, this whole concept of factoring out a GCF is the reverse of the distributive property. So if you were to distribute, you should get right back to where you started. So a slightly more complicated problem, 4x squared minus 18. One thing, I don't want you to get into the habit of thinking the first number is your GCF because that's not always the case. So here I cannot divide both numbers by 4, but I can divide them both by 2. So again, no variables in common, so it's just this 2 that's going to be on the outside. So 4 divided by 2 is 2. Keep my x squared. 18 divided by 2 is 9. Let's see, let's say we have 14x to the third minus 7x squared. So a little bit more complicated. Again, first number is not always the GCF. So the biggest number I can divide by here is going to be 7. Now, when we look at our variables, we do have variables in both terms now. We have 3 in the first term, 2 in the second term. So we're looking for the maximum number of variables that you can take out of both terms. So the most that I can take out of both always has to be your smallest number available. So the most I can take out is 2. So the 7x squared goes on the outside. 14 divided by 7 is 2. And if you remember from our exponent properties, when we are dividing, we subtract exponents. So 3 minus 2 is 1. So it's x to the power of 1. Now, a lot of times here, we would just say, oh, look, this cancels out, so there's nothing left. However, if you do that, you run into a problem because when you try to distribute, you don't have anything left to multiply by. So keep in mind, if the only thing that's going to be left, or if there's going to be nothing left, there has to be something. So 7 divided by 7 is 1. 2 minus 2 is 0, so there are no x's. So we end up with 7x squared times 2x minus 1. So one more of these, if we have 14x cubed, I don't know, let's go minus 16x squared plus 4x. So the biggest number I can divide all these by is 2. And the maximum number of x's I can take has to be my smallest number available, so just 1. So this 2x goes on the outside, and I'm dividing and I'm taking away an x. So 14 divided by 2 is 7. This is 3 minus 1, which is 2, so I have x squared. 16 divided by 2 is 8. 2 minus 1 is 1, so I have an x. 4 divided by 2 is 2. 1 minus 1 is 0, so I don't have any x's. So that's a GCF. The next thing is factoring a trinomial when a is equal to 1. So remember these trinomials, ax squared plus bx plus c. we're essentially saying we don't have to worry about an a value because it's just 1, which doesn't do anything for us. So the whole idea of what we do here is we multiply to get the last term, add or subtract to get the middle term. So a couple of quick examples of that. If we have x squared plus 3x plus 2, multiply to get 2, add or subtract to get 1. So if you can identify what numbers you multiply to get your last term, then we can verify in this case 1 plus 2 gives us 3. So when we factor, we set up our two binomials. What do we multiply to get x squared? That's x and x. Multiply to get 2 is 1 and 2, and those do happen to add to 3. Okay, once we start changing the signs around and we start getting more factors, that's when it becomes a little more difficult. So multiply to get 14, add or subtract to get 5. So my factors of 14 are 1 and 14, 2 and 7. So there's no way we can use 1 and 14 to get 5. So those are out. So we have 2 and 7. So from here, we have to decide, are we going to do 7 minus 2 or 2 minus 7? And we want to end up with negative 5. My rule of thumb is always that the bigger number keeps the sign. So if I want it to be a negative 5, I need it to be a negative 7. So when I fill in my binomial, I'm going to have x plus 2 and x minus 7. And remember, guys, this is the opposite or the reverse of FOIL. So you could always FOIL these binomials together, and that's going to get you back to your original problem. Okay, x squared minus 10x plus 9. Factors of 9, 1 and 9, 3 and 3. We're trying to get them to add or subtract to give us negative 10. So in this case, 3 and 3 are obviously not going to work. So it has to be 1 and 9. The thing we have to be careful about here is our signs. So in order to get a negative 10, that means both of these have to be negative. Because if we do negative 1 plus negative 9, that adds up to negative 10. But negative 1 times negative 9 gives us a positive. So just be mindful of your signs. So one more of these. X squared plus 4x minus 12. The problems do tend to get a little bit harder when you have more factors. 12, for instance, has 3 pairs of factors. So this might be where your multiplication chart's going to be helpful. So now if you can list out your factors, then just go through which pair of factors is going to give me 4. If I add, I get 13. If I subtract, I get 11. So that's no good. If I add, I get 7. If I subtract, I get 1. So that's no good. So it has to be 2 and 6. So now to get positive 4, again, my rule of thumb is that the bigger number keeps the sign. So if I want it to be positive 4, then I put the plus with my bigger number. So I have x minus 2 and x plus 6. And the last little section here is going to be when a is greater than 1. So again, we have ax squared plus bx plus c, but now we have a number for a. Now this is the kind that nobody was really a big fan of, and we tended to not be as good at this method. This was what we called our guess and check. So if you do nothing else, guys, please practice some of these because we're going to see some of these again. So a couple of examples here. Let's start with 3x squared minus 2x minus 5. So it's the same general idea. We have to multiply to get 5. We also have to multiply to get 3x squared, which we've been doing up here with our first terms. It just wasn't a big deal because we just had to get x squared. So it was just x and x. Now this time we have a number on the front. So we have to figure out how to multiply to get 3. So 3x and 1x is going to be our only option because 3 times 1 gives us the 3, x times x gives us the x squared. Now with our factors of 5, this one works out nice because 1 and 5 are the only factors. So the guessing and checking part comes in of where do they go. And I'm going to use a pencil for this because if I put them in like this, Our guess and check method requires that the inside products and the outside products add up or add or subtract to give us this -2. Well, if I look at this, 3 times 5, that's 15. That is so far away from 2 that this does not seem like a reasonable answer. So that's where the guessing and checking part comes in. I've guessed, I checked it, and it didn't work. So what I'm going to do is I'm going to switch it. So now 5 times 1x is 5x, 3x times 1 is 3, and I can now use 5 and 3 to get -2. Bigger number keeps the sign, so it's going to be -5 plus 3. Now, if you just follow the lines, that is how you are going to make sure you fill the signs in appropriately. So we end up with 3x minus 5 and x plus 1. Let's try 5x squared plus 19x plus 12. So starting off with 5x squared, that's the easy part because the only thing we can multiply to give us 5 is 1 and 5. So 5x and 1x. Now our factors of 12, like we saw above, we have lots of choices, which is why this guess and check method can be such a pain. So let's start guessing things. Now with 1 and 12, I obviously do not want to put 12 here because 12 times 5 is 60. That is so far from 19. So I'm not even going to guess that way, but I'll try this one if I put 12 and 1. So now as I look at my inside and outside products, I get 12x and 5x. Well, that's pretty close, but it's only 17. So that means that one's not going to work. So 12 and 1's out. Now we go to 2 and 6. Again, same logic. I'm not going to put 6 here because 6 times 5 is 30. That's too far away. So I'm going to try 6 here. So this is 12x and this is 10x. That's 22. Close, but again, not exactly what I'm looking for. So I can rule out 2 and 6. So now 3 and 4. And hopefully it should be kind of obvious how we're going to put this one in. I wouldn't put 4 here because that's 20. 20 plus 3 is not going to work. So if I fill it in like this, I get 4x and 15x, which does indeed add up to 19. And since everything's positive, I can go ahead and fill in plus signs. So one last example. Let's try 3x squared minus 8x minus 4. So multiplying to get 3x squared is easy, 3x and 1x. Multiplying to get 4, it's either going to be 1 and 4 or 2 and 2. So let's guess and check. 1 and 4. Well, this gives us 1. This gives us 12. 1 and 12 does not give us 8. So we could switch it. 4 and 1. This is 4 and 3. That gives us 7, which is pretty close, but doesn't work. So we can eliminate 1 and 4. So the nice thing about 2 and 2, it doesn't matter where they go because they're the same. So 2x and 6x, that gives us 8x. Oh, and I'm sorry, I wrote this wrong. That should be a plus 4 there. So same thing we saw up above with our signs. To multiply to get a positive, they either have to be both positive or both negative. Since we want it to add to be a negative, that means they have to be both negative. So there's a little factoring review. So hopefully, like I said, you guys will try some of those problems and hopefully that kind of refreshes your memory.